Hi guys, welcome to another tutorial of MySQL database administration. And today is not like about database administration, but today is about what's new in the new release which has been released by MySQL a few days back, and that is MySQL 8.0.23, and the previous version was 22 obviously. And this was the maintenance release released by MySQL, and this has a lot of good features involved in MySQL. And obviously MySQL team and the community team is working a lot on this, and they have done good work. And the good thing is that they were on time and they released the version on the time they specified, and that's the good work going on. So this is a deep dive session on what's the amazing thing I liked about this new version, and that's what I'm going to tell you guys. Yes, there are a lot of things they have done, but things which I liked the most and which I wanted to share with you guys, and which is the most attractive features new has been added or the new enhancement has been made. So that's what we are going to discuss today, and let's do that. So you can download it from here, and the new MySQL release notes can be seen on this here as well if you want to visit. And then you can visit this page and you can see that a lot of they have provided this index, and you can go through this page, and there's a lot of things to read. If you see here, scroll down, there are a lot of bug fixes and there's a lot of things which has been done, but things which I have picked up today and which I wanted to discuss with you guys. Let's discuss that first. So okay, the first and the most good thing which I liked about this release, that is that they have added this invisible column. Why do you need invisible columns? That's the main question you should know. Before that, how you add and how you create invisible column, that is a very simple thing. It's just that after specifying the data type, all you need to do is that specify the invisible. Of course, you can insert values into that as well. That values will be inserted into that invisible column. But when you select that select static from this table, you will see only those columns which does not have this invisible keyword specified. Just like in this one, if you can see here, we have done select static from T1, and all we are going to get is that F2, because F1 is invisible, so you cannot see that. And if you select like F1 and F2 together, you will get the null values from that. So that's how things are working. Now, why do you want to have this invisible column in your schema or in your table? The reason behind that is that in case you have the big schema and maybe a lot of tables which doesn't have this primary keys, and in case you want to add any primary keys or any new column, but you don't want your application to break down, and you don't want your application queries to be passed again or rewrite them, because application can be big enough that this might require a lot of redevelopment. So in order to take care of that, this is the main thing which you can use. And of course, if you want to your single instance, your single MySQL server to be converted into InnoDB cluster, then obviously there are some problems with the InnoDB cluster tables which does not have this primary key. So you can add an invisible primary column to your MySQL table, and then take that column as a primary key, so you don't need your application queries to be rewritten. And in case you are doing select static inside your queries, then obviously if you add any column and which is not invisible, then your application will break. Obviously some pages will break. That's because you are not rewriting your queries and you are changing the structure of the table, so that's gonna make a lot of problem. And the second thing, that if you want your single instance to be converted into MySQL InnoDB cluster, then There are some compatibility issues with the tables which does not have these primary keys. If you configure your instance, then it will tell you that these tables are not supported because they don't have the primary keys. MySQL InnoDB cluster does create some hash table for that, but it's not these InnoDB hash tables are not reflected on the secondary servers. So that's why if you are selecting from those other secondary instances, then you're not gonna get the same result, or just the same result on on the primary server. So that's where this primary server comes into hand. And yes, if you want to remove, then just specify the visible column. Okay, so you can remove that. So you can alter it as well in case if you want make that visible, if you want the column to be visible again. So that can be done as well. So this was the main feature, this was the key feature which has been added into this. And the next feature is encryption in DB log writer files. Okay, sorry, double rot file. Thing is, when you do some changes, what MySQL does inside this InnoDB architecture level, if you see here, this is the double write file. So when you do some commit, what MySQL does that from the buffer pool, it writes to the double, once the checkpoint has happened, it also write to the double writer buffer file as well, and also write to this your permanent data file as well. That is something else how it writes. If you want to know that, you can refer to my InnoDB architecture 1-hour lecture, and you can check that here as well. But we are talking here about encryption. What happened is that if you have enabled your tablespace encryption, then the data which you are writing to your data files of a specific tablespace which is on which encryption is enabled, that pages will be encrypted. But obviously MySQL write the data twice, once to the double write buffer and once to the data file. So the data which has been written to a double write buffer, which is here to these files, it will not be encrypted. So that was the problem in the previous version, but now this problem has been solved, and both the data of the double writer buffer and the data file will be encrypted. And the good thing is that they use the same key which is used for the data file pages and the buffer pool as well. So that's the overhead which is not happening here. So it's not costly, and it's really performance efficient. So, and the same key is used, and that's why if you see here, the same encryption page that will be written to the data file of the tablespace is also written to the double write file. So the pages are the same which has been taken from the buffer pool. So that's the good thing. So that's why it's very good for in terms of performance as well. Okay, next thing is that they have made a lot of enhancement in once you create the connection to your MySQL server. So the authentication has been made more deterministic, and now they know. Before they were what they used to do, that they will scan the whole everything, and then it will take a lot of time, like if an application is creating or disconnecting again and again, and it's creating a lot of connections and breaking up. So that was a little bit of very performance intensive, and now they have break it to some deterministic approach, and that's a lot of easier for now. And then what they have done, that they have brought some new privileges in the account management section, and that is for in case you want these privileges, which is flush optimizer cost, flush status, and flush user resources, and flush tables. That was before combined together was in the reload privileges, and you will have to specify the reload privileges, and then a user will have all these 4 of the privileges. But now you can, on the very more granular level, you can assign any of these privileges, and you won't be needed to provide any reload privileges to a user. So that's how they have like provided more granularity on the privileges level. The word is a bit of like hard to pronunciate for me. So okay, so that was it about the account management. And the next thing they have done is that is what already have been told in MySQL 8 earlier version, that they are going to like deprecate that slave, master and slave thing. So now in the replication thing, what they have done, that they have deprecated these words master and the slave, and they have come up with the new reserved keywords. And so what the first thing they have done is that they have a statement which is called change master to, that is been deprecated. You will receive any warning, like they will see your notification note will be given to you if you use change master. They will tell you that this has been deprecated, and in the next few version they will remove it. So it has been now changed to change replication source to. So this word has been changed to this one, and the parameter for the statement also have alias now, and that replaced the term master with the source. So the master is now called as source. So if you see here, master host, master port can now be entered as source host and source port. So this is the changes, and now the start replica has now been changed. The start replica is new word, and the start slave was the old one. So now we will call it as start replica. And the master log position and the master log file position has now been changed to the source log position and the source log file. So these are some deprecation which has been done, which is like the prominent deprecation. There are others too as well if you go through the document which I have shown you in the first slide, but this was the main thing which I have collected from the document, and which I have read, and which I was more interested to show you guys. And the next thing has that GTIDs, and this is something good like they have done to the database here. It allows direct data flow between the non-GTID replication setup and the GTID replication setup. So user is now able to replicate from GTID disabled source to a GTID enabled source replica. So without any other middleware upgrade procedure. So you do not need to upgrade it, or you do not need to like I have an article about this, that how you can migrate from non-GTID replication to GTID based replication, and that takes a lot of steps involved in it. So now that steps are not anymore required. What you need to do is that all you need to do is that enable an 18.0.2 replica instance, and then if you have any like source which doesn't have this GTID replication enabled, then you can transfer your data to another new instance like this version, and you will be able to transfer or replicate your data to the target which is GTID enabled. So, and this is also like good and a very good feature in case if any cloud provider which does not support this GTID based replication and without GTID replication. So that can be useful for you guys if you want to migrate to Oracle Cloud or AWS RDS. So, and any Azure or something like that which might lack this feature. So this is useful. Okay, the next thing is that this is a very good feature, and this has been asked by many of the users in the background in the previous time, and which is like I have a group replication, and then I have a asynchronous replication to another receiver. So like I have a group of 3 servers which is like working as a group replication here, and then I have this server which is my slave, you can say, and I'm replicating from this server to that server. So what happened is that the problem we used to have that let me open up Paint, okay, and I will tell you here. So it will be like more easy for us to understand. Let's say I have this instance, I have this instance, and here, and in between they have this group replication here, okay, sorry, group replication is happening here, and then I have this asynchronous replication here to my receiver 1. So the problem is here that what we will first, the router was involved here. Okay, before now you don't need the router here. The problem was that I have to tell this my receiver that like there are 3 servers which are involved in here, 1, 2 and 3, and there are 3 servers which are involved in group replication, and if you are receiving data, then you will receive from 3 servers. And in case anything failure happens, and let's say this one, the one got failed, and now this one is the new primary. So this is a problem for this one, because it was first replicating from 1, okay, and now 2 is the new primary. So we will have to manually tell this guy that now 2 is the new primary, and all these changes will have to do it by ourselves. And in case I want to add another instance, number 4, number 4 comes here, and now I have to tell him this one as well, that you have now 4 number is another server has been added to your group replication, so you have to update this as well. So these were the so many things involved manually. So if I tell you those scenarios which MySQL mentioned that we have covered here, which was mentioned to us by the user, and that was here. The first story is that, just like I've told you, that a new member joins. Let's say that MySQL was here, if you see here, from S1 it was sending data to R1, which is the receiver, and let's say S3 join in. Then you have to manually do that and add the S3 here as well. So now what it does, that S3 is automatically added to the metadata of R1, receiver 1, and this is solved. Okay, so now you see here S3 joins sender group, and sender list on R1, which is the receiver, which was initially S1 and S2, it's now automatically updated to S1, S2 and S3. So this is the new feature which has been added. And in case, let's say I remove one server, let the helicopter pass, then we will continue here. Okay, so what if this now let's say that S3 leaves the group. Okay, so S3 leaves the group, then first we had S1, S2 and S3, then now automatically it will update its list from S1 and S2. So S3 is gone. So these thing has been automated as well. And the most of the good thing, let's say I have 5 instances in my group replication, like S1, S2, S3, S4 and S5, and let's say that if the network partition happen, like the network breaks between server, and the quorum happens, like 2 instances are working separately and 3 are working separately, then my receiver, which is the asynchronous replication happening to the other slave or the target, then he should know that which is the quorum, which is the highest, which partition have the highest number of members in their group replication, and it should automatically connect to that one. So if you see here, we have a cross here, it should not connect to this S1 and S2 quorum, it should connect to not quorum, but that is the partition, and this is the quorum. So this should connect to S3, S4 and S5. So this thing has been made automatic in the new release, which is 8.0.23, and obviously it's a good achievement, and this is a good thing which they have done. And one more thing, that if we have a setup and of S1 is sending data to R1, which is the receiver, and let's say and another S3 has been added with the higher weight. Let's say another service has been added to the group replication and which have the higher weight, then the replication, my server, which is the receiver R1, should automatically connect to the server which have the highest weightage. So this was the requirement by the user, and MySQL, this release solved that problem as well. So this is a lot of big achievement here as well. And let's say automatic failover, let's say we have S1, which was if you see here, S1 is sending data to R1, and then what happened if R1, we lose the R1, then let's say S2 was having the highest weightage, then we should MySQL should have done this now R1 should be connected to the S2 because S2 is the new primary. So that problem has been solved here as well. So a lot of automation has been done here for the asynchronous replication from the group replication to the server, slave server, and this has like this is a big achievement for me as well, like doing this before using MySQL router and all that, and a lot of stuff was involved to achieve that high availability solution. So this is now good thing to achieve. If you want to know about more topologies of MySQL group replication and all that, you can visit my more tutorial on MySQL group replication and InnoDB cluster. You can check that as well. I have a pretty long 7 lectures playlist on that. You can check that. So this is what we have talked about, and yeah, this was a good thing we studied here. Okay, so one more next thing is that set table space auto extend. Yes, this was a very good feature which has been added here. And what happened is that it was like if you want to your tables to be auto extended, before it was auto extended, but it was like it was no, you cannot like stop your tables, or you cannot stop your table space like define them, like it was like specific. It was only one variable, and that will define that this all of the table spaces on this server will be auto extended by this number of value in terms of MBs or KBs, and that was static. But now they have like taken some good things, some good features from Oracle, that you can like if the server is like file per table space is on, then when you create the table, because once you create the table, then it will create a table space as well. So you can specify for a table that create table T1 and auto extend is equal to 4 MB or auto extend is equal to 8 MB and in case you are creating a table space like general table space or temporary table space, then create table space auto extend is equal to 4M and 8M as, and or you can do alter as well. You can change the auto extend value from 4 to 8, but the thing is here that it should be the multiple of 4, like 4, 8, and I think 16, yes, and 12 as well. Now there's a table which has been shown there. You can check that. It also depends upon the page size as well, so how much you should do that, but that's the example which I have shown here. So okay, the next problem, which was the biggest problem in InnoDB architecture level, which was that if you drop or truncate any table and your buffer pool is very high, like greater than 32 GB or like more than that sorry for my voice. So that was a tough thing, because let's say you select the whole table, like your 32 GB have buffer pool, and what you have done that along, like you have a table space or the different tables, like one table is like 16 GB, and when you select that, obviously it's gonna dump it to the memory and it will be inside your buffer pool. Once you delete that or you truncate that, obviously there are a lot of space which there are a lot of pages which has been written by that table, and what MySQL have to do is that it will scan the whole buffer pool, and it will check that which page is allocated to the particular table or particular table space which we are going to truncate or delete. So that was the hectic for the MySQL InnoDB architecture, that it will scan to the whole buffer pool, and even if a single table is deleted and it doesn't have, it was like 1 MB, still it will have to go through the whole buffer pool and it will scan it, and once it's deleted, then the prompt will be, or the notification will be given to the user. So it involves a lot of hectic things to do that. So if I give you here, like let's say this whole buffer pool is like used by this table space which we are going to delete, then it will start scanning from here to the tail, and you know that it's a long, if it's a 32 GB buffer pool, then it will have to check each and every single page related to that table space, and it's like hectic thing to do. So that was a performance bottleneck, and MySQL have done what they have done is that they have solved this problem by doing that. Okay, you issue a command truncate, and we will give you the prompt back. Then we will tell you that okay, this has been deleted now. We will mark it as a delete, and then you can do whatever you want to do next, and we will do it slowly, and we will do it later. We will do it on our own. Now the user have given this that okay, this was very fast, that the table was truncated very fast, but on the background we will do the job here is for our own things, our own way, and you can now use the server for whatever you want to do. But we are deleting that, but you don't know that we are deleting it. So that's have given a good gesture to the user that okay, I'm free now, I can work. So if you read this, that when the user either drops or truncates table space, MySQL will now mark it as deleted, then delete it files and report back to the user that the operation has finished. MySQL will then lazily free all pages belonging to the deleted table space from the buffer pool, or reuse them just like free pages. So lazily free all, lazily, slowly it will do it. So that's the thing. And the same thing was implemented as upper bound for mmap I think back allocation. So this is some memory allocation inside your temporary storage, engine storage. Okay, if you talk about this buffer, that faster truncate and faster drop table space, let's say the main problem here was with the temporary tables which were used by the any sessions. What will happen is that if a table, because the temporary tables was mostly of time created in the memory, so when the session will disconnect, the whole temporary table has to be deleted from the memory. So that was hectic. For every session, for every connection, it has to do all the rescanning for the temporary table and delete them. So now because of this new feature, they have done a lot of changes, and they have made it very easy, and performance wise they have done a lot of great work here. So that was about this presentation on what's new in MySQL InnoDB MySQL server, which is 8.0.23, and a lot of bugs have been fixed here. Like it's a lot of, half of this article is about bugs, so there's a lot of bugs which has been fixed. So obviously if you have some noticeable bugs in the previous version, then those bugs are not anymore here. And so that's it for today's lecture here, guys. And I wanted to mention what my favorite feature which has been added into MySQL InnoDB new version. And thank you so much, guys. If you guys have liked this tutorial, please mention other friends and like, share, subscribe. Thank you.